Hello once again. In this video I'm going to show you how to resolve forces that are acting on an object and thereafter show you how to calculate the Fnet of the system. Suppose you're given an object that is moving along the horizontal plane. The object has mass m and on it there is a force that is acting, which we shall call the applied force. That applied force pulls the object so that it moves along the horizontal plane to the right. As its direction of motion. The force is acting at an angle theta to the horizontal. Now, what you need to be able to do is you should be able to determine the forces that bring about the motion of the object along the horizontal plane. It is not the force that is acting at the angle or that resultant force that acts, but it is the component of that applied force that causes the object to move along the horizontal plane. That force or that component we shall call Fx. We do not know its magnitude, but we can determine it, and it will be a component which acts along the horizontal plane in that direction. At the same time, you need to be aware that there is a vertical component of this applied force. That vertical component would have a lifting effect on the object, even though it doesn't necessarily lift it off the ground. This component is what we refer to as the Fy component of that applied force. So if you are going to calculate the Fnet of the object that acts or that causes the object to accelerate or to move along the horizontal, we need to be able to determine that horizontal component, that Fx. From the look of the diagram, you can tell that this is a right-angled triangle, and this right-angled triangle has got two sides, the sides which we are calling your Fy and the side which we are calling Fx, and then there is the hypotenuse of the triangle, which is the Fap. From your knowledge of trig, you know that sine theta is equal to the opposite over the hypotenuse. In this case, the opposite side is our Fy, and the hypotenuse is the Fap, or the applied force, and this is going to be equal to your sine theta. So if we want to know the value of the vertical side of the vertical component of that applied force, we just need to make Fy the subject of that formula. And so what do? We simply multiply both sides by the Fap, and you will have your Fy being equal to Fap sine theta. Whatever the value of the applied force is, multiply by the sine of the angle theta, sine to the horizontal, and that is going to give you the Fy, or the vertical component. Consequently, if we are going to calculate the horizontal component of the resultant force, what we are going to look at, we are going to say the cos of theta is equal to the adjacent side, adjacent to the angle, which is your fx. So we know it's cos of theta is equal to adjacent over the hypotenuse, and then we just simply substitute the values as given on the diagram. So the adjacent is equal to your fx over the hypotenuse, which is our FAP, or applied force. That's going to give us our cos theta. Therefore, fx, if I multiply both sides by FAP, we're going to have FAP multiplied by your cos theta. That's going to give you the horizontal component of the force. It is this horizontal component which you are going to then use to calculate the Fnet of the system. So in other words, if you have, let us say there was another force that was acting in the opposite direction to that, and then you wanted to calculate the Fnet, you would then go on to do everything else that you've been doing in the past to calculate or to show the free body diagram, and also to then calculate the Fnet, which is equal to MA. Remember, when you have allocated or shown directions, you will then be in a position to calculate the Fnet of the system. So, given an example, if you have an object of mass, let's say 5 kgs, so you have an object of mass 5 kgs, and this object is pulled along the ground by an applied force of 32 newtons, and this force acts at an angle of 25 degrees to the horizontal. There is also a force that opposes the motion of that object, and that force is 8 newtons. We would like you to calculate the acceleration of the object along the horizontal plane. What is the acceleration experienced by the object along the ground? Remember what we said. We first draw our free body diagram. So our free body diagram so you'd have, here's our object, and then when you draw your free body diagram, when you've got forces that can be resolved, you can then say, okay, what are the forces acting? There's a force that acts to the left, which is 8 newtons, and then there is the applied force of 32 newtons. When you draw your free body diagram as it is, you should only draw the net force, and when you draw the net force, you cannot include on the same diagram the components of that force. So if you choose to draw it this way, you just show the net force, but at the same time there is the force due to gravity that acts downwards, right? There's the Fg, and then there's a small component of Fn, which if you look on the diagram is going to be smaller, because what happens is that this is going to contribute to the normal force. Then the sum of this plus the vertical component would give you the Fg. So this is the Fn that's there, plus the component that's going to come from the resolution of that force, applied force. And then that would be your diagram. And then from there, you can then calculate the net force and determine the acceleration of the object. Therefore, along the ground, so along in the y or in the horizontal plane, this is what we are going to then do. We know that our so let forces to the right be positive, and then our forces to the left are going to be negative. So we are going to say Fx plus minus our, if we choose to call it our FF, is going to be equal to our MA. So our Fx is equal to it's a component of that applied force, so it's going to be equal to 32 cos 25 minus the force that's acting against that motion, which is your 8 newtons minus 8, is equal to the mass, and the mass is 5 kgs, multiplied by the A, which is what you are looking for. You then make use of your calculator, and the calculator is 32 cos 25, so it's going to be 32 multiplied by cos 25 minus 8, and this gives you a value of 21,001, so which is 21. So this is 21 is equal to 5a. Divide both sides by 5, and then you are going to have your answer as, so it's divided by 5, and this is going to give you 4,2. So your acceleration is equal to 4,2 meters per second squared, and that is what you need. So it's in the horizontal plane. And if you were to calculate, right, what is, let's say you are then asked something like, what is the normal force Fn that acts on the object or experienced by the object? We said to you, the vertical, that's so that these are forces on the vertical plane. The forces that are acting on the vertical plane, obviously you've got your Fn, so it's Fn plus the Fy. These two forces act together and they are equal to your Fg. They act in the vertical, they're moving upwards, and so they're moving upwards, and Fg is acting downwards. So these two forces balance your normal, your weight. So in other words, you've got that plus the Fy component, and that gives you that value. So our Fn, which is what you are looking for, is going to be calculated as Fn is equal to Fg. So your Fg is the mass times force, acceleration due to gravity. The mass, that's Fg, right? Minus your Fy. Your Fy is your 32 sine theta, or sine 25. And then you can work out your Fg. N. So now when you substitute that into your formula, you are going to have your Fn being equal to the mass, which is 5 times 9,8 minus 32 sine 25 degrees. And then 5 times 9,5, you put that into your calculator. So it's 5 times 9,8 minus 32 sine 25. So 32 sine 25, put that into your calculator. So your answer is going to be equal to 35,48. So this is equal to 35,48 newtons. This is going to be the Fn that is experienced by the object. Take note, it is important for you to remember that if there is a force that can be resolved into the component, it's going to affect the value of Fn. In this particular case, even though the object remains on the ground, there is a lifting effect that is going to be contributed by the vertical component of the applied force. It is unlike if the only force acting were horizontal, then the Fn would be directly equal to your Fg. Very important that you remember this here. If you like the video, please share, subscribe to our channel, and see you in the next one.